Hello to a new episode of our live webinar series Agile TD Mondays. This time with Llewellyn Falco and his talk about approval tests. But first, I would like to announce that both for papers as well as the registration for the Agile Testing Days 2017 is open. You can submit your proposals and also book your tickets now. Enough said to me, I give now to you.
All right. Hello, everybody. I am Llewellyn Falco. I am a tester and a programmer and the creator of ApprovalTests. I live out here in Finland, and I'm an Agile consultant. So I go around and I work with different companies to help them get better at their coding practices and get their code in better places. And I want to share to you today a new technique. Well, not a new technique. This technique came out for us around 2007, so almost 10 years ago now, but still hasn't made it to a lot of places, so it's still probably new for you. And it's a lot different. So this is going to be a little bit of a stretch. We're going to do it very condensed, but I'm just going to ask you to sort of work through it, keep an open mind to the way this works, because I have found this to be really beneficial for me and really beneficial in the places where before we would say, hey, this is something that we just can't test. So let's get started. As I said before, we're going to talk today about approval tests, which is a specific library for approval testing, which is a more generic concept. We're not the only library that implements this philosophy. So first of all, approval tests is just an assertion library. You've probably seen regular asserts, right? So we have that first one, just assert R equal. And you might even be familiar with fluent asserts, right, which allow you to write in a little more Englishy type things, like message should be hello. Approvals is the same type of assertion library as fluent asserts. It sits underneath your testing framework, and it just gives you an easier way to write that assert. In particular here, it would say approvals.verify the message, right? We'll get into the details of that later, but I want to start by just saying this is not an alternative to your testing frameworks. You can use this with and in addition to any of the frameworks you're currently using. And when I say any, I'm a pair programmer, so we have this in quite a lot of languages. Java.NET, Perl, Node, PHP, C++, Python, Ruby, Objective-C, and Go. So if any of those languages apply to you, this is an option that you have. If you go to GitHub-approvals, that's where most of this stuff is sort of home-based. And then the other concept I'm going to need to introduce is the concept of the testing circle. Again, this is going to feel a little foreign, but as soon as we start doing it, I think it will feel natural. And the idea here is, let's not create our tests in code. Code is a very complicated way of thinking and creating. Let's start at the whiteboard, sketch out the idea, the scenario that we want to test, and then we're going to take it through this process of taking that whiteboard sketch, solidifying it a little bit more into English, then turning that into code, and then producing a result. Again, this might feel like familiar or unfamiliar, but as soon as we start doing our examples, I think you'll feel really, really at home. So let's take our first example. In this scenario, we have an Excel file. We have a couple of Excel files, right? Because we have one part of the business that gathers data for the customers, another part that's taking the orders, and they're creating their own files, and then we have the warehouse that's shipping out those orders. And all of them end up with these CSV files, and we want a program that sort of takes them and takes this very raw data and sort of combines it. So we get a customer who has orders, and those orders have shipments. And so the question I have is how would you test that? What would the asserts look like for that test? We're not going to answer that question right away, but we're going to come back to this question. And I just want you to sort of think about it, because it's this kind of thing that approval tests is very well suited for. But let's start way, way simpler. We're going to start with just the Roman numeral kata. I think this is maybe a very popular kata. It's a very simple situation. And here's our whiteboard, right? For Roman numerals, 4 is represented as IV. So that's a simple piece of whiteboard. Let's look at the code that comes out of this. So over on the left-hand side, we have this code. This particular example is in Java, so it's going to be JUnit. And we're just using the standard assert. So assert equals IV is the Roman numerals dot convert of 4. On the right-hand side, we have the approval test. And first of all, you'll notice there's 2 boxes, right? Because approvals is always 2 pieces. There's the part that's in your code, right? In this case, approvals.verify Roman numerals convert 4. And then the corresponding place where the result is held, where the answer is held, which is IV. And I think we can see right here that approvals is not winning this battle, right? And this is why approvals works with other frameworks, and I still use regular asserts all the time when I'm writing unit tests, right? At this point, we have more complexity sitting on the approval side. Even though it's still losing, I just want to get it a little bit better, because if I was going to do this, I'd still like it to be a little more clear. So I'm going to add just a little bit of text. You can see here this string, just to give a little explanation. And all that does is it changes that resulting approved file. And now it says Roman numerals 4 goes to IV. And that just makes it a lot simpler if I get that file to have some context. Like this is that whiteboard, right? And the whiteboard's going to get erased. It's not going to be around later, but this will still be around. And so if this ever goes weird, I now have some context of what's going on. Now that I have this context, I can actually write this even a little bit different. So let's just expand it a little bit more. Now I'm using a verify all instead of a verify. And that allows me to pass in a list of numbers, in this case, a list of the number 4, and have this little operation that converts all those numbers. And so this code has gotten a little bit more complex. We still have a really nice approved file, but I think it's still very clear that standard assertions are still much simpler at this point. But let's go a little bit farther down this path. It's not just, we don't want just the one Roman numeral to work. We'd really like a lot more of that. So let's do the test cases from 1 to 20. All right, so here's we are on the whiteboard. Let's go to the code. So over on the left-hand side, we have the code that is the normal assertions. You can see it's fairly repetitive. I don't think there's any mistakes in there, but you can definitely give it a look. The nice thing about this is there's duplication. I'm not sure that's always the nice thing, but at the very least, it's simpler to keep writing. You don't have to recreate the wheel each time, but there is a lot of work involved in writing all of this code. On the right-hand side is the approval. And you'll notice all I did is I changed from saying, hey, instead of giving me a list of the value 4, give me a list from 1 to 20. And then down in the approval side, you can see, again, it looks a lot like what we wrote on the whiteboard. 1 goes to I, 2 goes to II, 3 goes to III. I want to talk about that approved file for a while, because there's a question of like, how do we create that file? And the answer is we kind of don't. What actually happens is when you run this the first time, there's no expectation for that approved file, so it's going to fail. And when it fails, ApprovalTests will pop up a diff program. In this case, it's using diff merge, but it'll be different depending on what's configured on your system. And when it opens this up, I can look at this. I can visually inspect, hey, this is not working. Over here is what I expect, which is nothing. And over here is what I got. And when I look at it and say, hey, yeah, that's what I want, I can push this button up here that says move this over to the right. And when I click that button, it will move everything over to the right. And that's how you create these approved files, right? They're usually single click to go and create the file that you want once your code is producing the desired result. Hit the save button and we're done. I've expanded this now to go for all 5,000 Roman numerals. Right? Roman numerals actually only go up to 4,999. But to change this for the approval case, all I have to do is change 20 to 4,999. Now, how does this compare to what people would actually do when they're writing unit tests? I wanted to go to the actual real world, and Roman numerals is a fairly common kata, as I mentioned. So I went to GitHub and I just grabbed some code on there. And over here on the left is just this guy's code that he posted. Now, one of the things that's interesting about this is he actually doesn't check all the numbers either, right? What he's doing, if we zoom in there, is a bit of spot checking. So you can see the cases here that he's checked, right? He's checked about 15-ish cases. And the thing is, when I went to generate my file, I actually just copied his resulting code because I'm lazy. And when I ran it through approvals, I found out that his code had a bug in it, very specifically around 4 or 9, where it wasn't doing the IV, but it was doing 4 I's. Now, his sample set doesn't hit this, right? And is that because he doesn't have a good sample set? It was actually because, well, I'm not sure why it was, because I wasn't there with him, but my sample set wasn't better because I'm more diligent. It's better because I'm lazier. It took less work, significantly less code, for me to say, give me all 5,000 answers than it took him to do these 15. And because I was lazier, I got to explore a bigger space, right? Now this, of course, this is only part of the approved file that will go on for a lot longer, but it's much easier to actually see when things go. And it also brings in the case that if something was to explode or throw an exception, I would also get to see that. So it's much easier to do bigger tests, much easier to be more complete. Let's try moving up a level of complexity. So I'm going to do the game of life kata here. Game of life is a little simulation where cells on a board die or born based on rules. And it gets to the key part of approval tests, which is if you're going to be using approval tests, you need ways of representing the objects that you have. A lot of times we'll use stuff like XML or JSON, or just we'll write a toString. I think like maybe the first step into moving into approval testing as a technique is just to start putting some descriptive toStrings on your objects. But here we have an object that is much harder. So here we have a grid, and we start with 3 cells. And then when we advance the turn, those middle cells die and switch and are born. This is actually something in a game of life called a blinker, right? So if we were to advance this again, we'd actually go back to the first state. But let's write this up as a test. First of all, let's turn it into English, right? Because the picture is very good, but it's a little bit vague on the English. So we create a board, we populate the cell at 0, 1, we populate the cell at 1, 1, we populate the cell at 2, 1, we advance to the next turn, and then this is the part where approvals comes in, we verify the board. That's that statement right there saying, let's verify the board. That's the part that's missing with regular certs. You don't have a way of saying that. So let's look into this. This one's in .NET, but they're basically the same thing. You can see that the first parts are pretty simple. Create the board, right? So new board, place cell, place cell, place cell, advance the turn, and then finally verify the game, and in this case, the game.toString, right? So a textual representation. And you can see that the way that this shows up is just this little 3x3 grid with, hey, we got the 3 things in a row. The corresponding regular assertions here, I would need to assert all 3 of these places are alive, that the ones there. That doesn't exactly test the same thing. Like if we want to be a little more thorough, we'd also include the 2 cells that died. So these 3 cells are alive and these 2 cells are dead. It would also be good to test that we didn't have any other cells just pop up alive. So let's test the other remaining cells and just make sure that those are still empty. And then again, it would also be good to test that our board is actually a 3x3 board still. Okay, now we're complete with what we got. That does it. Now, that's a lot more work, but I'm still not actually entirely happy with the approval side because we're showing the end result, but we really sort of want that whiteboard experience. So normally I would change this just a little bit, add 2 little captures of text, right? One that gets us at the first stage and one that gets us at the second stage. And once you do that, you can see on the output, here's our starting thing, and here we are after we advance the turn. And that really tells me that whole story. That's super helpful if these tests ever fail, because it instantly reminds me what's going on. I get to see the trees and I get to see the forest. Because it really, really looks like that thing I had on the whiteboard. All right, so let's talk a little bit about how this gets built, right? Because one of the things that's interesting is the tools you have and the way you use the tools, they shape the way you think. And it's not magic, like words aren't magic, but what it is it's habits, it's patterns. The tools you have shape the patterns that form in your brain, and that shapes your actions. Your habits are really powerful. And so once you start thinking and start going to the white paper or the whiteboard and drawing these scenarios, you really quickly come across this scenario, right? Which is like a complete scenario for game of life. This is one square that's completely not surrounded by anything, and one square that's surrounded by one square, and one square that's surrounded by two squares, and one square that's surrounded by three squares, and 4 and 5 and 6 and 7 and 8. And now we have like a complete test. And hey, if this works, we've basically tested everything we need to know about game of life. You would think this would show up all the time. Game of Life is a really popular kata at code retreats, which I highly recommend you go to. But these almost never show up at code retreats. Because when you try to think in code, when you don't have the language to say, let me verify the board, you start thinking in really weird ways. The way you create your tests gets defined by this desire to spot check the results and check these little small pieces of the results. But I still want those little pieces like to emerge as I'm developing. So let's start by looking at what it looks like if I do this test-driven. All right, so again, test-driven, we write the test, we write the code. It's a little bit confusing. The test part is, if we expand it, is we write the test that create the result, and then we also create the expected result, and then we write the code. When you do approvals, this gets a little bit inverted, so that you write the test that create the actual result, you write the code, and then you create the actual result. Except for, of course, creating that actual result is just pushing the button. So really you approve the expected result. So let's go through this process. First, I'm gonna this is where I want this board to occur. So I'm gonna start with just seeing like, can I get a board? So here I have a board and it's empty. And that's going to be like my first requirement. It's the first thing I'm going to need to get. Hey, I can create an empty grid. Next, I need to get those things on the grid. Good. So now I have sort of two features. I have a grid and I can put things that are alive on it. Then I'm going to need to be able to advance my turn. Great. When I advance my turn, of course, nothing's going to happen at first. That's going to come as we go. But one of the first things that would be nice is, hey, if the stuff that was surrounded could come back. Now, the weird thing about this is this is bad functionality. This is not exactly what I want, but it's a stepping stone towards where I need to get. This is anything that has any neighbors. Let's move to something that has two neighbors. Those are supposed to stay alive. And actually 2 or 3 neighbors. Those should stay alive. And if a cell has 3 neighbors and it's dead, it should also get born. So let's get it so it spawns. And you can see, even though this is one sort of higher level test, one happy path, I can drill out the 6 independent behaviors. I can, from that, step by step, and get that granularity as we go across. So let's go back to where we started with this Excel, where I have the 3 different CSV files that need to come together. Well, let's turn that into English. It's actually really simple English. Combine the customer data, order data, and shipment data, and verify the results. 2 lines of English should be 2 lines of code. And it is. So first, I'm going to go over here and say combine customer data, order data, shipment data, get my results, and then verify. And this time, it's really nice to express this as JSON. So verify as JSON the results. And then, of course, I'm going to end up with this approval file as well. Notice in this case, it's .json because JSON file. This is, of course, not the full JSON file, right? This is actually just a part of it. But you're going to go, as you go through it, you're going to move it over little piece by little piece, just like we built up the game of life, you'll build up, hey, I got, my customer data had 5 customers in it. I got 5 customers. The customers have information around them. I got that information. They have orders. I got the orders. The orders have the information. This might take you quite a while to go. And it's one of the things I see is when I'm doing traditional assert-based testing, I usually end up with sort of a one-to-one, one line of test for one line of code. When you can start harnessing the power of approvals, I usually end up with a 60-to-1 ratio, 60 lines of code for every 1 line of tests, right? Because my tests are more powerful. So that's everything. I hope you enjoyed it and opens your eyes to like what you can do to test a lot more powerfully with approval tests. Thank you.
Thank you, Llewellyn. If you have questions when you're watching this, then you can contact Llewellyn on Twitter, or he also has a LinkedIn page, or you visit his blog about approval tests. And now I would like to tell you who's going to be my guest next week. Next week, Jean-Paul Barrick is going to talk about how to shift left DevOps the right way. And I'm looking forward to his talk. And I hope you tune in as well. Thank you, Llewellyn, for joining me. It was a pleasure having you.
Thanks.
So I hope to see you soon and have a nice day.
Bye.
Bye.